you'll see that the graph, there's this circle that's moving around, this point that's moving around the circle. And you'll notice there's a blue line and a red line, and the coordinates keep changing. So if I press pause here, for some reason it's not wanting to let me pause it. There we go. You can see that t, actually I'm going to drag it back to 0. We see when t is 0 or about 0, there we go. We start out here at 1 comma 0. When t is equal to pi, roughly pi, it's over here. When t is 2 pi, we're back over here. And so you can see t is really the angle of the graph. And so if t is 0, we have a radian measure of 0. If t is pi over 2, we're at 90. T is pi, we're at 180, and so on. 3 pi over 2 and 2 pi. And the coordinates then, if I look at this blue line segment, that blue line segment is going to be, didn't mean to do whatever I just did. At one point I shifted the radius here and didn't mean to change that. All right, so if you take a look, this blue coordinate, or this blue line, matches the length of the y-coordinate. So the blue line is just the y-coordinate, 0.841, and the red line is the length of the x-coordinate. So when you see the red line, it's the x-coordinate. The blue line is the y-coordinate. So if we go back here, you'll need to click on each of these. Apparently it doesn't like that. I'm glad I already opened these. So in this video, I'm going to take a look at sine and the unit circle. And so here, we're going to press play. What's happening here? Whoa, that's cool, huh? Take a look at that blue curve. Any guesses on what's going on here? Okay, then hopefully you're seeing a little clue there as you watch those two line segments being very, very similar, right? Notice the two red line segments are always the same length. So what's happening here is we've just graphed part of a sine curve. If I take the angle, so right now you can see t is at pi. The y value of the point on the circle is 0. And then if you look at the horizontal axis here, that is my angle. So when my angle is pi, the sine of pi is 0, the y-coordinate there. And if I continue to play this, we can see that this blue curve is just graphing the angle and the sine value, or the y value of the circle. And so we see the unit circle is related to the sine curve here. So basically, if you can think of the unit circle, you see that the unit circle is going around and there's an angle that's always changing. And that angle is, I'm going to pause it here. It will unwind it. You can see as that angle unwinds that every angle has a matching height or a y value on the circle. And so this is just putting all the angles on the x-axis and all the y values in the circle, the heights of the circle as the y values, and you end up getting the sine curve. So let's take a look at cosine. Go ahead, we're going to hit play. Now this is a little different. You'll notice we're looking at the red segment in the circle, but the red segment in the circle does seem to match the length of the red circle on the function. Okay, so you see that relation. If we look at the next box, number 6, what happens to the point of the function when the point on the circle is to the left of the y-axis? So right now the circle point is to the left. Do you see we're below the x-axis? In a minute I'm going to go to the right. The point is now to the right of the y-axis, and you see we're above the x-axis. Okay. You see here the x value is positive 0.897. And I don't know if we can highlight it. Yeah, the y value there is 0.897. So this is looking at all the angles. So if we look at the circle, all of the angles on the circle have a matching x value. So right now, the angle T is 5.825, which is getting close to 2 pi. And so that angle, you can see, is over here on the function curve, 5.825. And then the x value of the circle here, 0.897, becomes the y value on the graph. So really, as this unwinds, you can see each angle of the circle really has a corresponding x value. So each angle has an x value. So we can think of this as a giant table, if you want, a bunch of x values from the circle and a bunch of angles from the circle. We then take all of those angles and make them the new, I don't know what to say exactly, the new x values on the curve, and we take the x values from the circle and make them the y values on the curve. And so hopefully that's helpful. Let's take a quick look at tangent. All right, so this is interesting. If we press play, we're going to see a new line. You see this red line over here? This red line over here is called a tangent. It just intersects the circle once, and then it goes to the x-axis. Now, if you take a look, there's some interesting things that happen here. You see the red line over here. It's definitely different than the little horizontal red line in the circle, but it is the length of this tangent line. And so as I hit play, you see, whoa, something crazy happened right there, didn't it? And if we watch, it's going to happen again and again. So watch that tangent line on the circle. Do you see it? Do you see the tangent line? Boom, it comes out and then it comes back in. And so we see here, the length of the tangent line compared to the angle in the circle gives me my new function. Now, what happens I guess I'm going to pause and go back to tangent. We've been using the definition tangent as y over x. Same thing's happening here. If you take this blue y divided by x, the red line here, you are going to end up getting, you are going to end up getting that value. So right here, you see the blue line is close to 1. The red line is really small. So if we take 1 divided by a super small number, like just type in your calculator, 1 divided by 0.1, or 1 divided by 0.05, you'll see we get a huge number. And so that's what's happening. So we can think of the tangent function, the tangent curve, these blue curves, we can think of them as the length of this tangent line from the circle to the x-axis, or we can think of it as the y value over the x value. It's always the same. All right. The last questions here. What happens to the point of the function when the point on the circle is on the x-axis? So if I adjust t so the circle's on the x-axis, what happens to my tangent? You see my y value over my x value is 0, and also the length of my tangent is 0. So what happens then when I have my tangent? The point on the circle is on the y-axis. So right here, I'm almost there. Do you see this tangent line get super long? And when it's exactly, I don't think I'll be able to get it there, but when it's exactly on the x-axis, there isn't a tangent line that intersects with the x-axis, so it's undefined, it's infinite. And so you see on this curve, we end up getting these vertical asymptotes. So you could see at 0, pi, and 2 pi we have zeros, but halfway in between at pi over 2, 3 pi over 2, the tangent function's undefined. Hopefully that's helpful. I know there's a lot of information here. If you're not able to fully comprehend all of it, that's okay. Key point, though, is really just being able to sketch the tangent function, the cosine function, and the sine function. And so this is meant to help connect the unit circle to those functions. If this all just went right over your head, my suggestion is to really focus on the